at the time, the typical imaging time was around about 10 minutes or more, and for point scanning it was something like an hour to get an image. And here I was in this in my presentation talking about a technique which could produce an image in something like 20 milliseconds. And of course this left everyone dumbfounded. They really couldn't grasp that you could actually get an image that quickly. And I think some people even dismissed it as being improbable nonsense or something. Echo-planar imaging, or EPI technique, involved first of all having a static magnetic field so that you could polarize the spin system. Secondly, there is a selective pulse which defines a slice of material. The slice selection process, which defines the slice, has to be applied in the presence of a gradient. So let's call that the Z gradient. So the Z gradient is applied momentarily. A slice selection pulse, which defines the slice thickness, is fired off, and immediately after that pulse is applied, the Z gradient's turned off. You have then basically you've brought down a thin slice of material so that it's rather than being aligned along the magnet axis or Z axis, it's now in the XY plane. And if you can just freeze time for momentarily, you then switch, once it's here, you then switch on the X and the Y gradients. So it's a very quick switch from Z axis to the XY plane, and then in the XY plane you apply a series of modulated pulses to produce a set of spin echoes, and then at the same time a third axis which broadens these spin echoes as a function of time. So it's all done sequentially, except the last bit where the X and the Y gradients are applied at the same time. As far as the image is concerned, we sampled the data points, so that all these echoes that are formed are sampled one after the other, and then that data as a complete string of data points is like a bead necklace, and each bead is a point in the image space, and then a single Fourier transform of this whole bead of whole row of beads is done, and it turns out that that's the quickest way to do things. But these days I think people don't, because computing has come on enormously now, they don't bother to do that. They actually do what they call two-dimensional Fourier transform rather than one-dimensional, which is what I did.